Hello students, how are you? I hope you are doing well. Welcome back to math lesson. My name is Mr. Sadar Sud Muhammad, and we are going to continue talking about Earth is a sphere, and today we're going to discuss about distance along small circles. If you remember the previous lesson, we talked about distance along great circle. Okay, can you tell me an example of a great circle? Yes. Example of great circle is an equator. Equator. Yes, another one. Which is meridians. Good. So these are examples of great circles. But our concern today is to discuss about distance along small circle. Can you remember what is the formula provided to calculate the distance along a great circle? Yes, nice. The formula is given by arc length is equal to pi r theta over 180 degrees as r radius of the earth. Very good. So that is our formula that we used it to calculate the distance along great circle, or we said an arc length along the great circle. So the issue here is very little bit different. We have great circle, but now we have small circle. Previously we discussed about great circle, but today it has been changed to a small circle. Okay, let's check the diagram there, the figure above there. We have two circles here. This one, in which its radius is the same as the radius of the earth. This is the earth. And we have another circle here, in which the radius is smaller than the radius of the earth. So, if the circle in which its radius is equal to the radius of the earth, we said that is a great circle. So now, any circle in which the radius is not equal to the radius of the earth, that circle, we call it a small circle. So you can have small circles here, small circle there. In fact, all latitudes make small circle except equator, which is latitude 0, which is latitude 0. So this is a small circle. But if you draw another, let's say if you draw another an equator here and make a circular one, so this can be another small circle, because the radius here is smaller than the radius of the earth. Okay, so now the issue behind there is to find out how can we calculate the distance from on the arc length on the small circles. Let us now try to observe this diagram here. We have the radius and radius, but also these. Who can tell us what is this? The blue line. What does the blue line represent? Yes? Radius. Very good. This also is a radius of the Earth, which is the same as the radius of great circle. So we are supposed to find out the relationship between the radius of small circle and the radius of the great circle. Good. If we make a right-angled triangle over there, if we make a right-angled triangle over there, and find out cos of alpha, cos of alpha. If you remember trigonometric ratios, what could be the value of cos alpha there from the figure? Because we have this kind of figure now. We have this small r, this big R, and this is alpha. And we said, suppose this now is a right-angled triangle. So what is cos alpha? Yes, cos alpha is equal to adjacent here, which is R over hypotenuse of the triangle there, which is big R. So cos alpha is equal to R over small r. No, small r over capital R. So now, can we find the value of R there if we make it a subject of the formula? Yes. We can say R is just equal to this multiplied by over there, because times R here and times R there, and here times R. So this R and that R will make it 1, remaining only one small r there, and this is equal to capital R cos of alpha. So, can you tell us what is the relationship between small r and capital R? I mean, the radius of small circle and the radius of great circle. Yes, the relationship here is that small r is equal to the radius of Earth times cos alpha. And alpha, this is the angle subtended by the arc here, or the arc of the small circle. So simply now we can change. This is for great circle. Now for a small circle, it is simply that arc length is equal to pi, our R here, we want to change it, it is pi small r, because it is a small circle, then theta over 180. It has to be this one. If this is for great circle, then this should be for small circle, because great circle, the radius is just the radius of the Earth. But for the small circle, the radius is not equal to the radius of the Earth. So, but what is R? We have said that this R is equal to pi R theta cos alpha, the whole thing over 180 degrees, because we said this R is equal to R cos alpha. So we have to substitute R cos alpha here, which is R cos alpha. The remaining is pi theta of 180 degrees. So simply, to find the distance, the arc length or distance along small circle, we just find the arc length of an arc subtended by the two radii by the angle theta from the center of that small circle. So if we know theta, if we know the radius of small circle, we just go direct. But if we don't know it, we can also use the radius of great circle, the radius of great circle, which is equal to the radius of the Earth. Now let's check an example. The example said the angle subtended by arc AB at the center of the parallel of latitudes of latitude 40 degrees north. Yeah, the angle subtended by the arc, so it have to be what if the angle subtended by arc AB at the center of the parallel of latitudes of 40 degrees north. If A is on the meridian (25 degrees east) and B on 55 degrees east. Let me correct it here. Find the length of arc AB. Okay, we have this example here. The angle subtended by arc AB at the center of the parallel latitude is 40 degrees north if A is on the meridian 25 and B 55 both east. Find the length of arc AB. Okay, so let's come back to our formula here. We say arc length for small circles. How do we know that this is a small circle or great circles? We check if this is north, south, east, or west. We said that latitudes are lines running from north to south. So if the coordinate, if the cardinal letter of the latitude or of the latitude is north or south, that means that is a latitude. Otherwise, if it is east or south, east or west, then that is a longitude. So all latitudes are small circles except the latitude 0, which is equator. So this should be a small circle. Okay, our formula is this one. Arc length is equal to pi r theta cos alpha. The whole body divided by 180 degrees. This is for small circle. That is for small circle. So, here we are given the angle alpha, which is 40. Angle subtended by arc AB at the center of the parallel of latitudes 40. So our alpha is 40, and the angle theta here, we can get it from those given two meridians. From those two given meridians. So this is equal to pi, which is 2/7. R, we know the radius of the earth, which is 40,000 kilometer times theta. So we said we check if they are on the same direction, both are 25 degrees east, and this one is 55 degrees east. Then we subtract to get, so it will be 55 minus 25, which is 30. Then times cos of 40. Whole thing divided by 180 degrees. 180 degrees. So if we multiply and simplify, we can have 22 times 40,000 kilometer times 30, then cos of 40 degrees. This one divided by 180 degrees. So here we can say we have 6, but also we can simplify this one by here 11 and here 3. Now if you multiply the whole thing together, divide by 3, our answer is about 2,553. 2,553.7 kilometer. So this is the arc length of the arc AB due to the angle subtended by the arc and the parallel latitudes 40. If the meridian given is this one, 25 and the 55 degrees east. Are we together? Yes, good. So the concept behind here, there's no big difference from the grid circle and small circle. The issue is the radius. Grid circle, its radius is the same as the radius of the Earth, and the radius of the Earth is constant because it is already calculated, it is known. For small circle, the radius is the radius of the small circle, but if you're not given, if the radius of the small circle is not given, we can find the relation of the radius of small circle and grid circle, and we said radius of small circle is equal to radius of grid circle cos of angle theta. It's cos of angle alpha. Alpha is the angle subtended by an arc of the small circle at the center of the parallel latitudes. Okay, so now that's the whole concept behind distance along small circles. And here I have some questions to be done as your assignment. Okay, we have these two questions here. Number one, write down the relationship between small circles and grid circle. And number two, P and Q are 2 points on latitude 50 degrees north. The distance between P and Q measured the parallel of latitude is 149 kilometers. Find the difference between their longitudes. Okay, there is a word between here. Okay, so this is for our okay. Write down the relationship between small circles and great circle. Number one. And number two, P and Q are 2 points on latitude 50 degrees north. The distance between P and Q measured, between the parallel of latitude is 149 kilometers. Find the difference between their longitudes. Find the distance between their longitudes. Thank you so much for good cooperation, and let's call it a day. Until another time, bye-bye.